Hi there. In this video, I'll be showing you how to perform a fuel pump current draw test using a Pico scope and a low amp clamp. In this test, it will require you to hook into the fuel pump fuse using a low amp clamp and a current jumper wire of such. Alright, so I've located the fuse, used my jumper wire with the attachable fuse for that circuit, and I have spliced it into the fuel pump cavity for the fuse. Amp clamp turned on, set the 20 amp scale. For every 100 millivolts, it's equal to 1 amp. Where I find this is right on the meter itself. Amp clamp on, reset your waveform to 0 to calibrate your tool, and clamp around the jumper wire. Now, referring to the PC itself and the lab scope configurations, just going to give you a quick run through here as to how I have configured my scope to display the pattern. First off, I want to click on the channel A probe, and I want to tell the scope software which device I'm using. So I'm going to select the 30 amp clamp as my tool of choice for this test. Once I've done that, I've exited that. It's now calibrated. As for my amperage range, I know it's got a 20 amp fuse, so typically most fuel pumps will run within that range, a mid-range pressure pump. So I'm going to hit the 20 plus or minus 20 amp scale for this test. As for my time, I'm going to select a 50 milliseconds per division time frame. Right? This will give me a nice, clear, crisp picture, not too small, not too fast, where I'm able to measure the fuel pump's RPM. Down in the bottom corner, where it shows trigger, I want to set that to a single. And the reason for this is I want to see the pump turn on and then even out. I also do the repeat test, where this will allow for the waveform to continuously repeat itself. On a single frame catch, it will only show one frame snapshot and then it'll stop. All right? So for the first activation, I'm going to start off with a single. As for my current triggering point, I've got it set here just about 1 amp. Okay, and the reason for this is I want to be able to catch where that trigger gets turned on, so that way, you can see a little diamond here, I'm able to watch it turn on and then prime back up. Alright, so I'm going to hit on freeze. I'm going to go ahead inside and turn the key on. And I've got my snapshot. So what I'm going to do is scroll into it and decrease the wave pattern. And how I go about doing the decrease is menu bar, magnifying glass plus, magnifying glass minus will allow for me to view that pattern in a readable manner. So as you can see here, all right, pulling down and adjusting to my screen, pump turned on and displayed from left to right. Once I center this on the screen, so that way we can get a good view of this, what I want to do next is measure the current and the time the pump took to go over 1 revolution. And this is significantly important for checking for the speed and RPM of the pump. Bottom left corner, there's a white box. I'm going to point, click, and drag, and I'm looking for a unique pattern. So I spotted this one. That'll be the beginning of the event of the pump. Point and drag, a second line, and I'm going to point there. So what we're looking at in this screenshot is the beginning and the event of 360-degree rotation of the fuel pump DC motor. Okay. If you were to count each and one of these pumps, typically we run about 8 commutator bars. Okay, the average DC pump on automotive application will typically have about 8 bars. And if we look in the bottom right corner, the scope itself will calculate the RPM of the pump. So in this case here, we're running about 5,000 RPM in one revolution. The amperage is measured by viewing this horizontal line right across here. All right. Now, reminder, you need to calculate, so we're pulling about 198.6 milliamps, and that is reflective to its fluid pressure. But remember that the amp clamp is divisible by its segment. So on a 20 amp scale, for every 100 millivolts, it's equal to 1 amp, right? So I hope you've enjoyed this video and hope it helped out, and we'll see you on the next one. Thanks.